Hello, I'm Renee Knight with Autonomous Media here at Xponential in Orlando, talking to some of the exhibitors. I'm here with Avi Feinfold of Physical Logic. Thank you so much for taking the time to stop by.
Thank you for hosting me.
Yes, appreciate you taking the time. I know you're busy. These shows are always so crazy. So yeah, I guess if you could kind of start out talking a little bit about your company, and then we're going to talk about a new product you guys have coming.
Okay, so short introduction. Physical Logic was established in 2004. Actually, it was established for medical devices. The first device that the company developed was MEMS accelerometers for pacemakers.
Okay.
But in 2009, Israeli MOD saw Physical Logic technologies and its benefit and decided to go together with us to develop accelerometers for inertial navigation applications. So since 2009, Physical Logic and a big fab in Israel, Tower Semiconductors, developed together the accelerometer. Physical Logic is the developer. Tower Semiconductor in Israel is the manufacturer. And we designed together the ASIC. And Tower manufacture both the MEMS device and the ASIC. We have a production line in Petah Tikva near Tel Aviv, in which we have a nice assembly line and test line for the accelerometers. And this is what to do. We decided to show the world that MEMS accelerometers can compete very nicely with the traditional quartz pendulum accelerometers. And we are convincing, slowly, we are convincing the industry that yes, you can replace traditional technologies with MEMS, and this is what we are doing. Today we have two families of accelerometers. One accelerometer is open loop accelerometer, which competes with other MEMS accelerometers in the market, and the flagship accelerometer, the closed loop accelerometer, is really going down to accuracies of below 0.5 milli-G 1 year repeatability, which is really competes with the mechanical accelerometers. Today I came to talk about the new projects.
Yes, let's add.
So few customers that are interested in manufacturing navigation grade MEMS INS approached us, and today half a year ago we initiated a program in which we want to improve the accuracy from 0.5 milli-G 1 year repeatability to 0.25. So this accuracy really go deep into the navigation grade accuracies. And another mission was, if you can look at, I don't know where is the camera. This is the camera. If you look at this closed loop accelerometer, there is a lot of electronics on the backside of the PCB. And our task is to import all the dense SMT components from the PCB into the package. So we are going to move from this accelerometer, and we will have the full accelerometer in package level, with lower power consumption, better accuracy. And another benefit that will be that if, for example, you mount the accelerometer on a PCB on one side, if you have a miniature gyro that can be mounted on the other side, so just imagine that you can have a accelerometer and gyro in this size, and that can be integrated in a very small navigation grade INS, which can be used for many applications.
Can you talk a bit about some of the applications and the uses?
So the main application for the closed loop accelerometer, the open loop accelerometers are used for different type of applications, for seismic sensing, even for earthquake detection. but also for a type of border protections. That if you spread open loop accelerometer on ground, you can detect steps of people that you don't want them to step in this area. A very accurate tilt sensors, vibration sensing. We entered the structural health monitoring to detect crack propagation in different type of structures. And of course, inertial navigation, which was the initiative of this business. The closed-loop accelerometers, are mainly used for inertial navigation, but with the new project, it will be used also for north finding, target location, and navigation. Three operations that every soldier could have. So just imagine that you can build such a small INS that can be on a soldier helmet, and you can do all the operations from north finding, target location, and navigation in a small, cheap INS with our accelerometers. Another very nice application is for drones. You know that today package delivery drones, the main issue is safety, and the propeller of drones make vibration. Our closed-loop accelerometer are not sensitive to vibrations at all, so better than mechanical accelerometers even. So there is a very big advantage using the closed-loop accelerometers for this application. Another resource exploration. We provided the accelerometers to some customers for this application. So you need a very good accuracy for oil drilling for a long time. So it's small, very accurate, not sensitive to vibration. So it's very good also for oil drilling application. And yes, in Israel, we sell it to all the big military industries, so for different type of applications, mainly for inertial navigation.
Very cool, very cool. Well, thank you so much for giving us that overview. It's a really cool new product that you guys have. Anything else that you wanted to add that we haven't talked about?
Just one thing to add, that as I said, we are in the 250 MicroG project already, but our engineering team is working on a sub 100 MicroG accelerometer, and it's a big need, not only in Israel but in many countries, to go to the sub 100 MicroG, and I believe that in 2 years we will have this one. So get ready.
Very cool, very cool. So why is that so significant? Why is that such a
sub 100 MicroG was never, also 250 MicroG was never done with MEMS.
Okay.
In order to get into the 250 MicroG, we were dealing with many electronic challenges. Now to the sub 100 MicroG, we are already we find that we have to deal also with mechanical stresses. So we are really working on isolating stresses from the environment into the accelerometer, and we have already the first design. We even run some wafers to see that it works, and actually we are talking to some strategic partners, and we are looking for a strategic partner to go together with them on this project.
Very exciting. So you're thinking a couple years out.
Yes.
Very good, very good. Well, thank you so much.
Thank you very much.
Yeah, for sharing that information. We
It was a pleasure.
appreciate you stopping by, and thanks. Looking forward to the new product too.
Thank you.